Hello everyone, I'm your tutor AB and today we're going to be solving a question from the November 2020 IB chemistry examinations. This is an SL multiple choice question from paper 1A of the exam. It's worth 1 mark. Let's get started. A student obtained the following data to calculate Q using the formula Q is equal to MC delta T. Here we've gotten some data that the student has collected. Here we've gotten the mass. Here we've got the change in temperature, change in temp. And here is a constant heat capacity of water. Okay, so they're asking us what is the percentage uncertainty in the calculated value of Q. Okay, this is a different type of question because they're not asking us to find out Q or M or C or T. They're asking us to find out the uncertainty of the value of that I've calculated, not the value I've calculated itself. So how do I do this? Well, do you know what is percentage uncertainty? Percentage uncertainty is essentially just the relative uncertainties added up. And what does this mean? Well, the relative uncertainty, let's call it like relative uncertainty of the mass, right, this thing, plus the relative uncertainty of the heat capacity of water, plus the relative uncertainty of the temperature change. Now we know that this is a constant. C is a constant. There is no relative uncertainty for that. So we just need to add the relative uncertainty for both the mass and temperature, and I can find the percentage uncertainty in the calculated value of Q. And that's what Q is equal to. So how do I do this? How do I calculate this relative uncertainty? Well, relative uncertainty is equal to the absolute uncertainty, absolute U, divided by the measured value. Now, how does this relate to our question? Well, we can find the relative uncertainty for all of these, for both of these terms, M and T. Why? Because we know the absolute value for both the mass calculated and the temperature calculated or measured. For the mass, the absolute uncertainty is plus or minus 0.2, so 0.2, and the mass that they measured is 20.2. So for mass M, we can say relative RU for M is equal to the absolute 0.2 divided by 20.2. which actually, if I put it in my calculator, and actually this is not it, times 100, so times 100. And actually, if I put this in my calculator, I get that the value is equal to 3.02. Okay, I get the value is equal to 1. That's 1%. That is the relative uncertainty for mass. Now, RU for, in this case, temperature change, delta T is going to be equal to, what is the absolute uncertainty for temperature? Plus or minus 1. So 1 divided by, what's the measured value for temperature? 10. This thing times 100. And what does this actually give me? That's 10%. And what do I know? If I add these two together, I can get the percentage uncertainty for Q. So 1 plus 10 is equal to 11. So the percentage uncertainty of Q in this question is 11%. Thank you for watching. If you do have any questions, please comment below and I'll get to it as soon as possible. Please do like and subscribe. See you in the next video. Bye.